Okay, let's see what this question has to say to us. So it says, after a change in the side length of a cube, the cube volume increased by this percent. Which of the options is closest to the ratio of the original side length of the cube to the change side length? Okay, so let's try to kind of like visualize what is really going on. So it's basically saying after a change in the side length of a cube. So okay, so we have this cube with us. Okay, this cube. Okay, pretty nice cube. I like it. And let's say the initial side length was x, x, and x. Okay, the volume increased by 13%. So after changing the side length, the cube volume increased by 30%. So initially the volume was x cubed, but after a certain change, the new volume is increased by 1.33%. So what's this going to be? The new volume is going to be x cubed 1 plus 33.1%. This is going to be what? 1, 2. So it's going to be the new volume. It's going to be 1.331 times. So this is the new volume. This is the original volume. And the question is basically saying which of the option is closest to the ratio of original side length. So I'm looking for original side length to the change side length. So change. Okay, so original over x new. Okay. So let's see what's going on here. So first of all, I think what I need to do over here is kind of like try to come up with some type of relationship which will eventually help me find what's going on, because I have the change is in the volume, and the question is basically asking me about the sides, right? So if I somehow can find the ratio of the volume, let's say the original volume times the v new volume, and kind of like take the cube root of this, then that would be equal to what I'm basically looking for, which the question has basically asked me, okay? Which says basically over here, which of the options closest to the ratio of the original side length, which is the x, to the change side length, which is the x n new. So, okay, so the original volume is, so can I try to come up with easy to use numbers, because then it's gonna make my job a lot bit easier, because I really want to get rid of these fractions. So if I say if this is, let's say 1000, then this new volume, the new volume is just going to be 1, 2, 3. Yeah, so the new volume, it's going to be 1, 3, 3, 1, right? So it's basically, I've just removed these crazy fractions. All I need to do is take the cube root of 1000 and 1, 3, 3, 1. And if I take the cube root of 1, so I definitely know that cube root of 10 is 1000, but I'm not really exactly sure that if this is the cube root of maybe 12 or 11 maybe. Let me see. I'm going to use my calculator here to find out. So 11 times 11 times 11 is, oh yeah, okay. So I think everything checks out. So in reality, basically what's going on is this is basically 10 to the power 3, and this is 11 to the power 3. So if I'm basically taking the cube root, x over xn, which is the original side to the new side, is going to be 10 over 11. And all I have to do is probably I have to divide these two up. It's going to be something less than 1. 10 divided by 11. It's going to be 0.9 something. 0.909 something. And the answer is going to be, it's going to be B. Do you guys have any question relating to this one? Any questions?
No, I did.
Okay, cool.